Section 6.1 is called perfect squares and square roots. So first, in the first couple of videos, we're just going to talk about like what are square roots and cube roots and fourth roots, and then the rest of section 6.1 and then into 6.2 are simplifying square roots. But let's start off by just looking at this lovely multiplication table I made for us and talking about these numbers on the diagonal. The numbers on the diagonal are what we call perfect squares. So these are the perfect squares. And we call them that, I wrote it down here, we call them that because they come from multiplying a number times itself. So 12 times 12 is 144. 11 times 11 is 121. 10 times 10 is 100. So these are the numbers that we're going to use to simplify square roots. So perfect squares are numbers that come from multiplying a number by itself, or squaring a number from a number squared. So that's all we mean by perfect squares. All right, well, these are also the numbers that we can take square roots of. So these are square roots that simplify. So let's do some examples of those. So for example, 3 squared makes 9. So that means the square root of 9 is 3. That's what we mean by doing a square root. It's the opposite operation of squaring. So the number that squared would make 16 is 4. And since 4 squared equals 16, that means the square root of 16 is 4. The number squared that makes 49 is 7. And we do need to know these. So 7 squared is 49. So that means the square root of 49 is 7. So I'm hoping we already know our multiplication table and know these perfect squares, but if not, we need to memorize them. This chapter is not going to work out if you don't know these perfect squares. Let's do some that are a little more complicated just because they're fractions, but really using our rules of exponents, these aren't that more complicated, because remember, the rule of exponent says if you have a fraction squared, you can square the top and square the bottom separately. So we really just need to look at what squared would make 81. So in this case, that would be 9 squared makes 81. And what squared makes 64 is 8. So that means that 9/8 squared is 81 out of 64. All right, well, let's do the opposite. The opposite is square rooting. So just like we can separate squaring using using rules of exponents, we can separate square roots the same kind of way, where I can view the square root of the top and bottom as 2 separate pieces. Square root of 81 is 9, and square root of 64 is 8. So it's also the opposite operation of squaring, which makes sense, but I want us to see it in this way of viewing the top and bottom as separate square roots. So if we're looking for what squared would make 1 out of 121, well, 1 squared makes 1. 1 times 1 is 1. And 11 squared is 121. Or in the opposite operation, we could do the square root of 1 and the square root of 121 separately to get 1 out of 11, or 1/11. All right, so those are sort of our easy square roots in that they simplify down to either whole numbers or something that doesn't have a square root in the end. So even though these are fractions, at the end they don't have a square root in them. Let's try some more examples just to make sure we're okay with this, and then we'll see what the next page has for us. So square root of 81 is just 9, and that's because 9 times 9 is 81. If I'm looking for what number times itself is 100, that's 10. Now this one is just slightly different because it has a negative on the outside. As long as the negative's on the outside of the square root, that's fine. But as soon as we move a negative inside the square root, then that's not a real number. We will learn about imaginary numbers in this sort of next section, but for right now, we're just going to call that not real. This is a fraction, so we view the top and the bottom separately. Square root of 144 is 12, and square root of 49 is 7. Well, let's make a list, right? I've talked about how you need to know these. Just to be careful, let's make a list so we're all clear on what these perfect squares are and where they come from. So all they come from is squaring numbers. So I'm going to just start by writing out all the whole numbers squared. I guess we could start with 0 squared. 5 squared. And it says less than 200, so we need to make quite the list. 7 squared, 8 squared, 9 squared, 10 squared is 100, so we got to keep going to get to 200. And then 11 squared, 12 squared is 144. 13 squared, maybe we know that, maybe we don't. It's 169. We might start needing a calculator on this one. 14 squared, 15 squared. So let's make this list because these are the values that we should have memorized. To start with, 0 squared is just 0. But what that means is you can take the square root of 0. It's just 0. Similarly, you can take the square root of 1. It's just 1. These others are numbers that we need to really have memorized because when we start doing more difficult square roots, we're going to need to look for these numbers as factors. Look for perfect square factors. And every now and then, 49 or some of the higher numbers might be some of those factors as well. But a lot of the square roots we're going to simplify have 4, 9, 16, 25, or 36 as factors. So if you're having trouble, like keep writing that list. When we're simplifying square roots, these are the 5 numbers we're typically looking for. And then sometimes we might see higher numbers as factors, certainly. If you notice a number ends in 2 zeros, that means 100 is a factor, so we want to look out for that. 121 is an option. Did anyone figure out what 14 squared is? It's 196. Oh, so we got to our 200. I went out to 15 squared though, so let's make sure we have that on our list too. That's 225. Beyond that, I do not expect you to have any of the rest memorized. I mean, 20 squared is 400. I guess that's not too hard, but I don't know what 17 squared is off the top of my head either.